Hey, good morning, everybody. Thanks for attending this coffee break. It's really appreciated. We got some very interesting news today. And the topic of today's coffee break is going to be about software development at Eddyfi. And more specifically about Assist, which is our ACFM software. And there's nobody better than Noah Johnson, application specialist for the ACFM team, and Benoit Bergeron, who's one of our main software engineers for the Assist software, to talk about that. So I'm going to leave the stage to them. Enjoy, and thanks for attending again.
Thank you, Charles.
Okay, so hello guys. So today's topic for the coffee break is ACFM software developments, and we're going to give some quick demonstrations of some new features which have come out recently and that we want to show off so everybody's up to date. Today on the agenda, if we go right again, we'll talk about software development at Eddyfi, so you know how big we are, what our values are, and what we think about software here. We'll talk about the latest Assist software improvements, some key improvements kind of in detail and kind of demonstrate them so you know how they work. And then we'll take your questions. So off to you, Ben.
Yeah, thank you, Noah. So, software at Eddyfi Technologies. So, Eddyfi Technologies was founded in 2009 in Quebec City, where is the principal headquarters. And we have multiple offices across the world. We have lots of centers of excellence. We have also a few sales and support centers, all divided across the world. And also the software part is really important for Eddyfi because we have multiple employees dedicated to software development. For example, we have 650 employees that are working at Eddyfi Technologies. And in those numbers, there are 47 employees dedicated to software. And all those employees are working on great updates and delivering great value for software. And we have 13 major software products that are really proud today to discuss with you. And but first, we're going to talk about Assist, which is the latest update, and I will let Noah present.
Yeah, so as Ben said, so today we're releasing the newest update of Assist, and we're taking this opportunity to talk more about the recent developments in Assist that have come out in the past few years, just so everybody's up to date, because sometimes it gets kind of forgotten, but software is really important for us, and we want to make sure that you guys are up to date and are using the best that we've got. We're going to go focus on more advanced features, so stuff that maybe will be unfamiliar to you. If ever you want to learn more about ACFM, kind of the basics, how it works, what the applications are, I recommend you go to academy.eddyfi.com, where you can find an intro to ACFM course, and you can learn all about this stuff. And then you can maybe come back to the coffee break and learn about all the recent stuff that's come on. So we've released 3 major versions in the past 2 years of Assist. And our improvements have been mainly focused in 3 broad categories. The first being customer experience. So your day-to-day usage, you know, how you interact with the software and how to make it basically frictionless and easy to use and a pleasure, ultimately. We also focus on improved productivity because ultimately that's how we produce value for our customers through faster inspections, more efficient work. That's really very valuable. Finally, data exploitation and reporting. So the usage of the data that you collect, and like how do you analyze it, how do you report it, that kind of stuff. Okay. And today we'll give some examples of features we've worked on lately. Mostly Ben, actually, he's been working a lot on Assist lately. Okay, so looking at customer experience, obviously there's no hiding it. There's a lot of work that goes into just maintaining the software, keeping it up to date, compatible with various operating system versions, and just general bug fixing because that's part of life in software. Also, we recently released the OTA, so over-the-air updater. So kind of like on your phone, you get updates. You don't need to worry about plugging it in or doing much. You just say install. The same will now be available on the Amigo 2, starting with 3.3. That means any of the future updates will be really easy. You wanted to think about it, it'll just be offered to you. And that way you can just you can easily enjoy all the newest updates. Next up, we also introduced cloud licensing on the Amigo 2. That's important because it makes for a much nicer experience for the customers and for us. It's easier to use, and it's also easier to move your license around. So say you've got a desktop software and you want to move your license key to somebody else, like a coworker somewhere else. It's now you can basically do it in only a couple clicks, whereas before it was much more complicated. That's a really big improvement, which I highly value personally. Last but not least, there's the whole customer or kind of aid to the customers. So we released the new Get Assistance function, which has also been available in other packages or other software versions, but now it's available on the Amigo too. And it means that you can easily ask for help from the experts at Eddyfi. When you request help, we basically get a package of the data of interest, any important log files, and then we can analyze that, discuss that, and come back to you with help and assistance with whatever problems you might have. Could be analyzing data or whatever. Okay. Now, as for improved productivity, anybody that knows ACFM a little bit will know that you spend a lot of time doing detection, but once you find a crack, well, you need to find, if you're using a probe with no encoder, which is all the pencil probes basically, you need to find the beginning and end of the cracks so you can get a length estimate, which is then used for a depth calculation. And there can be situations where, basically if the conditions are poor, so it could be cold, it could be hot, it could be dirty, a dirty environment where, you don't really want to have to do that process because you'd have to kind of wipe it off a little bit more. You just want to kind of run your probe through there and get an instant estimate of what kind of the crack looks like. The other thing is that if you did use an encoder for this, encoders are moving parts. They would tend to get all dirty if there was, say, oil or grease on your parts. They wouldn't last that long, and they just wouldn't work in the kind of complex geometries which ACFM excels at. So really, this feature is really about saving time in terms of finding the crack depth and length. So now we can talk about a little bit how it works so you can understand it better. So if we consider the usual crack, so a fatigue crack, which would be a semi-elliptical shape, and we're looking at its BZ signal. So as we go over a crack, the BZ signal will have a trough and then a peak. Okay? Those are associated with the beginning and ends of the crack. So if we know the time at which we pass the trough, the first trough, TT, and the time at which we pass the peak, we can calculate the delta time. So we know the amount of time required to travel across the crack. If we have that, and we also have the average scan speed, well, then we can easily calculate the distance traveled, which is equivalent to the length of the crack. However, if you don't have an encoder, it's how would you know the average scan speed? Well, it's hard, but that's what this feature aims to solve. And so how does that work exactly? Well, with the 3BZ method, what we've done is we've taken the first coil and we've added a second coil ahead of the first coil and a third one behind it. So we actually have 3 BZ coils on each channel now. So what happens is that with these 2 additional coils, as we run the probe over a crack, we actually have 3 signals, okay? But we also, because the probes are calibrated at the factory, we know the distance between all these coils. So when you do a scan, we actually get these 3 signals, and given that we know the distance between all these coils, we can look at the average scan speed going over that crack, because we know all these trough times and the distances, so we easily calculate the average scan speed. And because we have so many coils, we can actually get multiple values, so it's actually an average, which helps with more precision, because obviously this isn't a perfect technique. It's made to give you an estimate to help you speed along, because there are cases where you don't need a very accurate depth. You just need to know an approximate value, and this is what it's for, really. So now that I've showed you a bit how it works, we can maybe move on to a quick demonstration. I'll just actually move back to the other slide. Okay, so a quick demonstration of how it works. So here this is what the 3-row array. We've got channels 1, 2, and 3. And on this probe, it's got the 3BZ features. So each channel actually has 3 BZ coils. And this means that this probe will allow for instant estimation of the length. And you can see there's actually no encoder on here, right? There's no moving parts. It's just one solid probe with a ceramic block at the end. So it's very durable. That's the point. So if we take this probe and we move over to the assist, so we're ready. We've already got a site set up, a component, and a part ID. We're just going to set the direction. So I'll use direction C. This probe actually has a remote, so you can change directions from A to C. You can start stop your scan, you can pause it, and if you've got a plan, you can actually even go to the next component. So here what we'll do is we'll just place the probe on. This is the function check plate actually for this probe. So it's got quite a few flaws, so it's kind of a busy plate, but it'll still work for the demonstration. So we're going to aim to have a constant scan speed, because the more constant the scan speed, the better the estimation will be for the crack length. If you're too jerky, the estimation could fail, but you could always do it again and just try to be more constant in your speed. In my case, it's kind of a small sample, so it's hard to do, but it's easier in the field. So we can go ahead and just press start, and now we'll see the scan go by. I'll just kind of move it at a constant speed. And there we go. So this is a 3-row array. So you can see on the screen, we actually have the 3 colors. It's 3 different rows. So now if we go ahead and hide 2 of those rows, so maybe we can just look at maybe row number 2. We can see we've got a transverse defect in the middle. We can see we've got, actually we have a shadow of the first defect. We have a transverse defect in the middle, and then a small defect, and then a large 50 by 5. So we can go ahead and try to size that one and see what happens. So we'll just go ahead and size it without going through the procedure. Just drag across the BZ. You'll see, so now we've got a length estimate of 44.7 millimeters. These, if you actually did the procedure, you'd find it's about 45. In this case, I got pretty lucky. This is very accurate. And we've got a calculated length of 50.6, depth 4.3. So it's not a perfect calculation, but it's instant, and it's in many cases good enough. And so you can just move on to the next, the inspection once you know this value. You can see we've got an auto estimate at the bottom here. That's the estimate provided by the BZ feature. And it gives us an idea of how constant our speed was. You can see the plus or minus value. The more constant the speed, the lower that estimate, the lower the range will be. If you're more jerky, it'll be greater. In this case, we were pretty good. So it's 45 plus or minus 5 millimeters on the length. So there we go. At that point, you can just add the defect like any old defects. And so you see, we've just avoided that process of finding the beginning and ends of the graph. That's a huge advantage. Now moving on to other features we've released to improve productivity. I will go back to the PowerPoint. Another important feature, which I think is not well known enough, is inspection planning. This is super valuable because it means that you can plan ahead. If you know what you're inspecting, you know all the welds, at your desk, at the comfort from a chair with a laptop and a mouse and a keyboard, you can plan your entire job. So you can set up your site, you can set up your components, you can set up your part IDs. Okay? And so you can write these all ahead of time, and you can have various different models. So it's actually quite versatile in terms of how it works, the software. But it means you can create your plan ahead of time, and then you can save it to USB. You can give it out to your guys, so you can easily distribute the plan, the inspection plan. And then everybody, all the inspectors have their plan already on their Amigo 2. And this leads to ultimately more repeatable results because it's the same part IDs, so that if you do the inspection again and again, you will always have the same part IDs, and it'll just be repeatable. It'll be easy to compare the scans to see if there have been any changes in the defects. So I think this is super valuable. And because you do it ahead of time, you can do it much faster than you would if you were doing it on the smaller screen of the portable instrument. So if we look about how that works, so say the example of here we have tank cars or gussets. There's generally, all these wells are already named because they've inspected in the past. So you can just take this nomenclature and you can transpose it to Assist, and you can enter all your models, so all the different variations of geometries that you want to inspect into your parts or into your components list. And then for each component, you can define all the different parts to inspect. So all different welds, so welds A1, A2, A3, however you want to name them. It's up to you, and the software leaves flexibility. So it's up to whoever's planning it to give the names, and it can adapt to most ways of naming your welds. Okay, that's it for the reporting. I'll leave it to Ben to give you guys some more information about the data analysis.
Yeah, thank you so much, Noah. Those were really cool and well features. So you have done your measurement, your acquisition, and now it's time to see your data. So you have two meanings for that. First, we have added a new feature, which is data info mode. This mode is really cool because right now you can see exactly each point in your graphics and what are the values, and also see the difference between 2 points in your graph, and I will show it to you. So this is the measurement that Noah just took a few minutes ago, and we have added inside the analysis tab here next to the region a data info mode. So if I click on it, it will display a dialog which represents my value of my cursors next to it. So I can move my cursor A and a cursor B. I have two of them, and also it shows the delta, the difference between those two positions on the x-axis and on the y-axis. Also, they are independent from the XBZ view and the XBX view, which is really neat. I can move them all around if I want, and it automatically snap to the nearest point in the graph. So one feature that I really like is to someone that is not really well known about the software, and especially about the graphics in the XBX and XBZ view. And we have the butterfly. It gives us a good understanding about when I move my cursor B, for example, where it moves exactly in the butterfly view. So, for example, if I move here, I can move here on the peak, and I can see exactly it appears on the peak in my butterfly view. So, which is really easy to understand much more how the butterfly view is working. So I can also it also work with a multi-row measurement. So if I go here and I open already, oops, sorry, let's open this. Okay, so I can snap my cursors on.
Go ahead and open the rows here.
Okay. Okay, sorry. Okay, the rows were all closed. Okay, sorry. Okay, I rip open here. If I zoom in, I can move my cursor to the nearest point on the next rows if I want. And it's really cool features because you can see the difference between two positions. So that's pretty much a nice feature because in the past you had to do some other behaviors to the same thing. Okay, so the two next features, once all your acquisition was done, you want to print a report. So right now we have added a features which is generate a report. It's on the backstage and in a file transfer box. This functionality right now is to provide a way to print multi-pages from a site or from a component. And what it does is print a single file, a PDF file with all the elements that you want to have inside that document. So if I click on here, the first page of the wizard dialog is the report summary. The report summary is going to be the first part of my PDF report. I have a few fields right here. I can even custom them if I want, customize them if I want. I can select, I can move them around if I want. I can type whatever data I want into those fields, and it will always display in the first part of my reports. And I can also add general comment in my PDF, which will appear also at the top of my document. So the next page of this wizard is which kind of information that I want into my data report PDF. So the first thing here is I can only generate PDF for a wall site or for only the current component that I have already selected. Also, I can select which kind of activities that I want to have in my report, a general, function checks, probe configurations, and also in the general inspections. For example, my customer just want to have defects only. I can just hit right here, defect only, and it will only print per component or per site the measurements that I have defects only that I've measured which I sized before. And also I can only print a defect and region. For example, if I added some kind of region in my data and also I have other pages with defects, I can combine them together and have one single PDF reports with defects and region. I can also select the scale that I want for my graphics. I want to also auto-center them or auto-fit them. And also I can ignore the Y field if I want. For example, if I am using a probe that don't support the Y field, I can make sure that this checkbox is checked. So the next step is I just hit generate, grab a cup of coffee, and then a few seconds later, the PDF will be generated. So I'm going to show you what exactly is the output of the PDF.
Wait, Ben, wait. And we're going to just show it first.
Oh, yeah. Sorry.
There we go.
Okay, we're changing the view. Okay, so this is the output. Like I've mentioned, the first part of my PDF report is the report summary, which are custom fields that I've just entered into the software. And the next part of that report summary is another summary of the whole report. So we have a table, an array here, which shows when your inspection starts for that specific component. And also another cool feature that I really like is on your computer, you can click directly to the first page of that component. So instead of scrolling down with your mouse, you can just only click here on the number and automatically, boom, it goes to the page according to the index. So it shows all the page in the report that I can click on them. And that's a really good report because I don't have any defects at all. So for each component, I don't have defects. But if I add some defects, it was the same behavior for first page. I will have a number here that represents the number of the page in the report, and I can click on it, and it goes directly to the page with the defects. Okay. So the first part is the general inspection, and we also, if you have other part, for example, you have function checks and also probe configuration, it will appear there just below the general inspection array. Also, you have the box for your operator and the signature, and you can also add the date of the report. And this one should be familiar with you. Is the same template that we use for each pages. So this is really familiar. We have different kind of information about the measurement. We also have the graphic here that represent your measurement. And we have added nodes, defect region, the settings, all the kind of settings that you are familiar with. So it's really cool to have at least one PDF, one file for all your different kind of reports. So that's pretty much it about the data report new feature.
I think we're about done with our coffee break, so we can probably move on to the questions now. So I hope you guys have been busy while we've been chatting. So we have some questions. So check that full screen. Okay, so we have a question from Melissa Sivret. Hi guys, how can we get the new software version? I can take that over.
Yeah, so yeah, you can go.
So now, granted, we haven't the OTA is coming on this release, so you will have to actually you will have to go download the new software from our website, and then you will transfer it to your USB key. You just put it on the root of the USB key, and you plug the USB key in to your Amigo 2, and then it'll automatically detect your USB key, and it'll just say, do you want to update? And you will say yes. You will select the exact version you want to update to, and then it'll just reboot, and you'll be on the new update. But now for all future versions, you actually won't even have to do that. It'll still be an option, obviously, because if your hardware isn't connected to internet, you can't do that. But if it is connected to the Wi-Fi, well then for all the future updates, all you have to do is you'll get a notification on your Amigo 2 saying that there's an update available, and then you just press on update and it'll take care of itself. Okay.
Hey guys, Benoit from Charles Tremblay. When you made the measurements, I didn't understand the units. What are the measurement units used? That's a really good question. If we go back to the software here, and I will show you the data info, like Jean-François mentioned, we don't have any units next to the amplitude here in the on the dialog. It's simple because when we are doing acquisition, we are acquiring raw data. And those they have not have any units at all because it's kind of a scale of bytes that we are used to represent the data. So it doesn't mean anything to have units right there.
So another question, is it applicable for thin material? Could you please mention the limit range of thickness that we can use this technique? So I imagine this isn't really a question about the software itself or any of the new features, but just about ACFM in general. So yes, you can. So ACFM is really it's a technique which is used mainly for structural welds. So generally, where you'll have cyclic loading and fatigue cracks, ultimately. So I don't know what you mean by thin material. It'd be nice to have some values, because thin, to me, thin is measured in kind of gauge. So ACFM isn't really normally used for very thin material. That's not what its application is for. You probably want to go for ECA if you're looking for very thin materials, because the welds will also be very small. It's more of an ECA technique. So generally we're talking about plates that have at least a few millimeters in thickness. In terms of the range of thickness, yeah. Oh, next question. Another question from Charles Tremblay: is ACFM more efficient than TECA for structural welds? Well, to answer that question, you need to kind of look at the bigger picture, because ACFM and TECA it's an interesting comparison. They both have their pros and cons. I think for doing inspections in the field, ACFM it's got more history. Ultimately it's a simpler software. It's simpler probes. Everything is made to be a little bit easier to use. Whereas TECA is incredible, and it's provided with Magnify and the Ectane, which has a world of possibilities, but it's not optimized for weld inspection and big welds. It doesn't have quite the same array of probes. So I would generally recommend more for ACFM, because the software is built for this. The software is simpler, so there's less places there's less knowledge required to kind of master the entire software. I generally recommend ACFM for structural welds. But if you have an Ectane, then TECA can work. So here another question from me, from Victoria. How can you get the position from the inspection datum without an encoder? The 3BZ technique doesn't seem to provide that. You're absolutely right, Victoria. So admittedly, with the 3BZ, the goal of 3BZ is not to locate the probe in space. The goal is really to provide an estimate of the lengths, which is ultimately what's important and what takes longest. The 3BZ allows you to get a quick estimate of the size. It doesn't give you the position relative to datum, but historically ACFM has used measurements from datum and clock markers to provide that kind of information. So it really isn't a problem when you consider the usage of ACFM. The other thing is, with an encoder, encoders aren't perfect either, especially in the complex geometries which you would use ACFM for. The encoder would slip. It wouldn't really provide you with proper information about where the defect is. So you generally wouldn't need that kind of information. You would probably measure it yourself if you wanted to add it to your report. Now, could you please, next time, how to size a real defect detected in the component? That's probably a good idea. Maybe we should do a kind of another coffee break, which would be a back to the basics, and we could just go through a quick, run through of a real part, a real defect, and just simple, plain old ACFM, just so everybody can maybe get to know that better. Because I guess we do focus on a lot more advanced stuff, and I guess for some people the basics are more important. Again, I recommend you maybe go look at the e-learning introduction, because there's probably a section where they show how to size a real defect in a real component with the standard technique without 3BZ or without an encoder, so the good old ACFM. So
if you have any more questions, you can contact Charles Tremblay at the email at the bottom of the video feed. And so that's it, I think. So thank you for attending this coffee break this morning. My name is Benoit Bergeron, and I'm with Noah. It was a pleasure to give you this presentation this morning, and have a good day.